Hello, this is Dr. Hassan with Innovate, and this is lecture number 65, State Assignments of Chapter 9, Design of Synchronous Sequential Network of the course Digital Logic Design or Digital Systems or Digital Electronics. This is a disclaimer for you to read. I cite 3 references in Digital Logic Design, however, there are many books available in the subject. In Chapter 9, there are 4 steps to design synchronous sequential networks. The first, and the most important step, is the derivation of the state graph. The second step is the reduction of state tables and state graphs. The third step is the state assignments, which is a very important step. The state assignments, having an optimal state assignment, will reduce the number of gates needed to implement the machine. Having the minimal number of state graph or state table will reduce the number of flip-flops needed to implement the machine. Now, 2 steps actually, we'll talk about it in the next 2 lectures, is the implementation and the implementation with PLD devices using VHDL language, which is VHDL Design 8. Optimal state assignments. In designing sequential networks, 2 different state assignments may yield vast differences in hardware. Therefore, searching for an optimal state assignment for the reduced state table is very imperative, very important in the design process. However, the number of possible state assignments for the sequential network is quite large. Unbelievable. For example, a 10-state network has 2.905943 times 10 to the power 10 state assignments, of which 75,675,600 are unique or distinct or non-equivalent. With such a huge number of state assignments, manual search for an optimal state assignment that would produce a minimum hardware would be impossible. Therefore, having systematic guidelines that will allow us to choose a reasonably good state assignment is very useful. Total state assignments. To understand total state assignments, let's consider a 4-state network with all possible state assignments as shown. Since the network has 4 states, 2 flip-flops or k is equals to 2, A and B are required to realize the network. Therefore, there are 2 to the power k of 4 ways to assign the first state as 0. So we can assign the first state as 0, 0, 0, or 0, 1, or 1, 0, or 1, 1. Choosing one of these assignments will leave 3 possible assignments for the state S1 because each state must have a unique assignment that is 2 to the power k minus 1, or the 3 ways to assign the second state as 1. Similarly, there are 2 to the power k minus 2, or 2 ways to assign S2, and 2 to the power k minus 3, which is 1 way to assign S3. So the total number of ways to have different state assignments will be 4 times 3 times 2 times 1, which will equal to 24. Now, those are the 24 state assignments shown: S0, S1, S2, S3, which is 0, 0, 0, 1, 1, 0, 1, 1. 0, 0, 0, 1, 1, 0, till 1, 1, 1, 0, 0, 1, 0, 0. Now, there are only 3 distinct assignments out of those 24. Okay, so we have 24 total assignments, but we have only 3 distinct. So many state assignment, why is so? Because many state assignment can be derived from other state assignment by either interchanging the 2 columns or complementing 1 or more columns. For example, state assignments number 3 can be derived from state assignment number 1 by interchanging the 2 columns. So, for instance, I have 0, 0, 0, 1, 1, 0, 1, 1. So if I interchange, I will get 0, 0, 1, 0, 0, 1, 1, 1. Just the 2 columns are interchanged. The same thing actually by state assignment 24 can be derived from state assignment number 1 by complementing both columns. So 0, 0 will become 1, 1. 0, 1 become 1, 0, and 1, 0 will become 0, 1, and 1, 1 will become 0, 0, and we get state assignment number 24. So by examining all state assignments, we find there are only 3 non-equivalent or distinct state assignments. And they are state assignment number 1, 2, and state assignment number 5. Okay, all other state assignments can be derived from these 3 distinct assignments by either interchanging columns or complementing one or more columns. And clearly that if we study this, 2 state assignments are equivalent if one can be derived from the other by permuting or complementing columns. 2 non-equivalent state assignments are said to be distinct. The number of the distinct state assignment increases rapidly with the number of states as shown in this figure here in this table. Therefore, we must follow appropriate guidelines to determine an optimal state assignment that we can use to realize the network. So this table shows you for 2 states, I need 1 flip-flop, so k will be equals to 1. I have 2 total state and I have 1 distinct. However, if I have a 3 states machine, I need 2 flip-flop, I will have 24 total and 3 distinct. If I have 6, I will have 3 flip-flop, 20,160 total state and 420 distinct. To see that number goes rapidly to higher and higher numbers to show you that this is an enormous task to find the optimal state assignment. So there are 3 guidelines which allow us to find the optimal state assignment. Guideline number 1, states that have the same next state for a given input should be given adjacent assignment. States that have the same next states for a given input should be given adjacent assignment. Now the word adjacent, it means they are adjacent in K-map or they are adjacent in a gray code. So adjacency will be established by having them really one next to the other in K-map. States that are the next state of a single present state should be given adjacent assignment. Present state which has the same output for a given input should be given adjacent assignment. We will come to the guidelines again when we look at the example. Now the procedure, how we use this guidelines. As a first step, we write down all the sets of state which should be given adjacent assignment according to guidelines 1, 2, 3. Sets of states with multiple occurrences will be labeled with a number of occurrences. So for instance, if the guideline will give me more than 1 set, okay, so we'll have really priority on this set which will repeat itself again. Using K-map to satisfy as many as possible of the adjacencies derived in Rule 1, sets of adjacency state with multiple occurrences must be satisfied first. So if I have multiple occurrences on a specific set, so I have to give it a priority. I have to meet this multiple sets. It is a good practice to assign the reset state to all zeros squared in the K-map of the K-map. This simplifies the initialization of the network. When the set of adjacent state has more than 2 states, this state will occupy 4 or more adjacent squares on the K-map. Priority is given to set adjacent state of guideline 1, then followed by those of guideline 2. If the next state combinational logic is our priority. However, if the network multiple outputs is the priority, we will put priority on guideline 3. It is sometimes impossible to satisfy all set of adjacent states, but with a fair amount of trial and error, we can satisfy the maximum number of adjacency sets. Let's look at this example. We have a machine. This is hopefully a reduced machine with 8 states A, B, C, D, E, F, G, H, and we are looking to find the state assignments for this machine. Now we go to the guideline. Guideline number 1 what we need in guideline number 1. We need the state that have same next state for a given input should be given adjacent assignment. Now, states that have the same next state, states that have the same next state for a given input. If we look here, the next state is here. Under x0, for a given x0, h does not repeat itself, does it? Does not repeat itself. F does not repeat itself. G does not repeat itself. A does not repeat itself. C does not repeat itself. B does not repeat itself. D does not. So under x is 0, we don't have really the same next states. However, here we have B under x is 1. The next state for A is B. And the next state for A is 1. B when the present state is H. So A and H is the first set. So those are the states that have the same next state for a given input, which is x is 1. So A and H. The same thing, if we see here A and A, the two states here, we need B and G because both of them, they have the same next state. Okay. Then we have C and F because both of them, they have the next state D for the given input x is 1. Okay, so I have C and F. Then I have D and E because both of them, they have the next state C and when x is 1. And by this, guideline number 1 will give me AH, B, G, C, F, and DE. Those are really needs to be fulfilled first. We have to find agency between A and H, B and G, C and F, and D and E. In guideline number 2 calls for a state that the next state of a single present state should be given adjacent assignment. Now, we have for state A, the next state are B and H. For the state B, the next state A and F. For the state C, the next state D and G. Okay. For the state D, we have the next state C and E, and for the state E, we have A and C. For F, we have C and D. For G, we have A and B, and for H, we have B and D. So guideline number 2 gave me those 8 sets. Okay, which we need to have them adjacent to each other. So we need B adjacent to H, A adjacent to F, G adjacent to D, C adjacent to E, okay, and A adjacent to C, C adjacent to D, and so on and so forth. In guideline number 3, we are looking for present state which have the same output for a given input should be given adjacent assignment. So the output here, Z, does not depend on the input for this machine. So the same output is state A, B, C, not D, E, F, G, and H. A, B, C, E, F, G, and H. Okay, so we have 7 states. We have to have adjacency. Now, once we finish this, the guidelines give me the states that needs to be adjacent. We go to K-map. We have the flip-flop, let's call them Y1, Y2, and Y3. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Always we'll put A in the 0, all 0 state. All 0 state, or this, or the M0 minterm, which is we put A here, A here. Now, the first adjacency I would like to establish from the guideline A and H. So I put H here. I could put H here too, because if you rotate the map as a cylinder, A and H here will have also adjacency. Okay. I wish to meet all guideline number 1, okay? So B and G, where I put B and G, I put them here. B and G, I put them here. Then we have C and F, D and E. C, F, I put them here, and D and E, I put them here. Okay, so I filled up all the map, all the 8 state, and I established adjacency with guideline number 1. Let me check guideline number 2. Is B and H, B and H, B and H? Unfortunately, I cannot meet B and H. Okay, I cannot meet B and H. A and F, can I meet A and F? I cannot meet A and F. See? G and D, can I meet G and D? G and D, G and D, I cannot meet G and D. So we met actually all the guideline number 1, however, we are not lucky with guideline number 2 because we cannot do them all. B and D, did we meet B and D? No, not B and D. So really, this assignment met only guideline number 1. How about guideline number 3? Guideline number 3, A, B, C, E, F, G, H. The only state is not, we don't need is D. So A, B, C, because A adjacent to B, B adjacent to C, and all of them adjacent. So really we can establish adjacent because we have 7 of them. Only D, we can exclude them. So we can say guideline number 3 is fully met, So this is one possible state assignment. Once we have all the state laid out, we say the A is 0, 0, 0. We can read it, 0, 0, 0. B is 0, 1, 0. B, 0, 1, 0. 0, 1, 0 for the state B. C is 0, 1, 1. So put them here, 0, 1, 1 will be assigned to C. Okay, and so on. H will be assigned 1, 0, 0. So we have the first actually option of state assignment. Let's try to do better. So to meet A and H, I put A here, and this is in the reset state, and H here. Still we have adjacency. And to meet C, B and G, can I meet B and G? B and G, I put B and G here. And I put C and F. C and F, also we have agency here. They are adjacent, C and F. And D and E, D and E. D and E also adjacent. So we get this after many trial and error. Let's look at guideline number 2, BH. BH, they are adjacent, B and H. And A and F. NAF is they are adjacent. We have F is here in this cell, so they are adjacent. Now, G and D, they are adjacent. See? So we did much better. G and D, so we met B and H, A and F, G and D, C and E. Did we meet C and E? C and E, no. It's far away. We don't have any adjacency between C and E. Okay. How about A and C? A and C, no, there is no adjacency between A and C either. How about C and D? C and D, no. So A and B, no. And B and D is no. So we met actually, we met all guideline number 1, and we met 3 sets from guideline number 2, and we meet all with the 1 set, which is all the states from guideline number 3, because again, all of them, those are adjacent except these, because A, F, E, B, H, C, all of them adjacent, and G, okay, and we said we exclude D. So this is much better actually, much better assignment. And A here will be 0, 0, 0. B will be 0, 1, 1. C will be 1, 1, 0. D will be 1, 0, 1. and E will be 0, 0, 1, and so on and so forth. So we have two actually possible state assignment, and this is much better because we met much more sets. Okay, so this should give me better really hardware than this one, or minimal hardware than this one. Let's look at the second example. This is much easier this example. We are looking for 4-state machine, and we are looking for a best state assignment or optimal state assignment. We have, I do apologize, this is a 5-state machine, A, B, C, D, E, and we have the next states. So we are looking for the guideline. In guideline number 1, we are looking for the state that have the same next state for a given input should be given adjacent assignment. So we see here, we have A and A appear under X0. Okay, for the state A and C. So A and C is the first set that we need to meet. Okay, the first pair. We have CC under X0, which is B and D, because both of them, B it has next state C and D has the next state C under X0. So B and D. Okay. And what else we have? We have C and E, because C has a D under X is 1, and E has also D, the same next state at X is 1. So this is will give me what? Will give me another pair, which is C and E. So I need to meet those three sets. Those are, they have the highest priority. Now, the next priority, I need the next state for a single present state. For state A, I have A and B. For the state B, I have CE. For the state C, I have AD. And for the state D, I have AC. And for the state E, I have BD. For the output, the state which have the same output to state A and C, okay, because they have the output 1, and state B, D, and E, because they have the output 0. They have the output 0. So the guideline gave me those. I need now, again, I will have more actually room to make trial and error and to get a better match for those states. So again, I will have two possible Y1, Y2, Y3. This is because we need 3 flip-flop. This is a 5-state machine, okay? And we will choose state A for midterm 0, 0, 0, 0, because this is a reset state, state A. Now, in guideline number 1, I need AC, BD, CE. AC, I put C here. Then AC is met. BD, I will put B and D here. Okay, B and D here. Then CE, I will put C and E here in these two cells. And I achieved all guideline number 1 sets. Okay, AB. AB is met because AB is met. Okay, what else we have? We have BD, we have CE. CE is met. CE is met. And we have AD. AD is not. We cannot meet AD. AC. AC is met. AC is met. Okay. And BD. BD is met. Also BD is met. So we have a lot of matches here with this state assignment. And we come with A000, 100, and C001, D101, and E011. And for another option or another solution to the problem, we have choose A here at midterm 0 at all 0 states. So A, then I will have A, C, I will have C down here. Then I have AB, also met from guideline number 2. BD is met. I will have BD here. Okay, is met. And I will have CE is met. CE is met. Then in guideline number 2, I met AB. CE is met. CE is met. So CE is repeated. So CE must do, okay, because it's repeated set. AD, we cannot meet AD. Okay. AC and BD. AC is met and BD is met. BD is met. So we met a lot really from guideline number 2 and old guideline number 1. Okay. Now AC and BDE for the output. AC is met and BD is met, but E not E. Not E. Okay, we cannot meet E. So, but AD is met. AD is met for the output. AC, I do apologize. AC is met. Okay, so with this, we have a better really state assignment in the second solution, where A is 0, 0, 0, B is 0, 0, 1, C 0, 1, 0, D 0, 1, 1, and E is 1, 1, 0. This is the end of this lecture, which is a super easy lecture of state assignments, very interesting lecture. I will thank you so much for listening. Please subscribe by clicking the circle, and hopefully to see you soon in the next lecture. Sincerely, Dr. Hassan.